Right now, humanity faces a cosmic danger most people never think about. Not giant planet destroyers, not tiny harmless meteors, but about 15,000 medium-sized asteroids we haven't even found yet. And we don't currently have a way to stop them if they decide to strike Earth. These city-killer space rocks could flatten entire populated regions. In this video, we'll unpack how scientists got this number, why detection still lags, and what it really means for our future. Scientists estimate there are roughly 25,000 near-Earth asteroids large enough to level a city if they impact at full speed, objects roughly 140 meters across or bigger. But here's the kicker, only about 40% of them are known and tracked by our current observation systems. That means roughly 15,000 are out there right now moving through space, and we don't know exactly where they are. Why does this matter so much? Because size matters for detection. Mid-sized objects like this don't reflect much sunlight and often travel in Earth-like orbits. This makes them extremely hard for optical telescopes to spot early, especially when they approach from the sunward side, where glare blinds ground-based systems. In effect, we have blind spots in our planetary defense network. This is far from science fiction. Recent planetary defense conferences have highlighted this vulnerability. NASA's acting planetary defense officer, Dr. Kelly Fast, admitted these undetected asteroids are what keeps her up at night. She explained that while we've cataloged larger bodies and no small ones won't cause catastrophic damage, these in-between sized rocks are the real wildcards. It's tempting to think we solved asteroid defense when NASA's Double Asteroid Redirection Test, DART mission, successfully bumped a small asteroid's moon and changed its course. But that demonstration relied on years of warning and preparation, something we don't currently have for most of these 15,000 unknown threats. Planetary scientists emphasize that a successful deflection mission requires early detection, often a decade or more ahead of any potential impact. Without knowing where an asteroid is coming from with plenty of lead time, there's no current spacecraft on standby to intercept and alter its trajectory. In other words, knowing where an asteroid is comes long before knowing how to stop it. That's why the upcoming Near-Earth Object NEO Surveyor space telescope is such a big deal. Unlike optical telescopes, Surveyor will use infrared sensors to detect the heat signatures of dark asteroids, a game changer for spotting those that don't reflect much light. This will dramatically increase our ability to find more of these hidden rocks before they're too close to act. This isn't just technical progress, it's planetary preparedness. The more we know, the better we can plan missions, coordinate global responses, and build systems that can respond with enough lead time to deflect a threatening object. Right now, that foundation is just being laid. So what does this mean for humanity? First, it's not an imminent Armageddon scenario. The probability of an impact in any given year is still low. But the risk isn't being ready for the unknown. It's missing something until it's too late. With roughly 15,000 threats lurking in blind spots, this isn't a minor oversight. It's a signal that planetary defense is still in its infancy. The real lesson? Seeing is the first step to saving ourselves. And that's exactly what the next decade of asteroid detection missions aims to achieve. Find these invisible rocks, track their paths, and build the tools we might one day need to protect our planet. Until then, scientists continue to scan the skies, watching, calculating, and preparing. Because we might be the only species in the universe asking these questions. Humanity has taken its first real steps toward planetary defense. But the sky is still full of unknowns. The real breakthrough isn't stopping asteroids. It's finding them early enough to matter. Everything now depends on how fast we improve our cosmic awareness. So here's the real question. Are we moving fast enough to spot the next threat before it spots us? Or could one of these unseen asteroids truly affect our future in ways we're not ready for? Drop your thoughts in the comments. I'm genuinely curious. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries. Your support truly makes a difference and helps this channel grow. Thank you for watching, and see you next time.